Okay, thank you. Thanks for joining, especially at this time. So today we are going to talk about the challenges of deploying a medium to complex cloud-native application across different environments, from your laptop to your Kubernetes clusters or cloud service providers. And so we will introduce you to tools that provide your application superpower, to transform your application to be super resilient, to gain some abstraction level and thus portability. But we absolutely don't want to sacrifice the developer experience. We still want the developer being able to test with confidence and to be able to not drift across the different environments, okay? So without further ado, let's switch to a first demonstration, okay? So that I'll set up the scene of our demonstration. So we're having a cloud-native pizza store, very simple application that allows you to place order for pizzas, okay? And you can see here on the top right corner that it relies on different components, a store, a pub/sub broker, a kitchen component, a delivery component. And so here I can place an order, add a pepperoni pizza, want a beer. I have to wait a few dozens of minutes, and you can see that the workflow is starting. So I've placed an order, the order is saved, the order is sent to the kitchen, the pizza is prepared. Then when it is prepared, it is sent to the delivery service that is bringing the pizza till home. Okay, so the delivery service is 1 mile away, 1 kilometer away, okay. Now the order has been delivered and it is now complete. Very easy, okay? And you can see this application is running on my Kubernetes cluster right here. You can see the pods right here. Okay, so looking at an architecture diagram, logical architecture diagram, we have 3 microservices, 3 components, the store, the kitchen, the delivery. The store is calling the kitchen and delivery using REST APIs. It's a synchronous blocking call, and the kitchen and delivery are sending back events once they are done with the preparation, and it allows the store to to send the notification back to the UI and the user. And if you want to have a deep dive in this application, you can check this Git repository, and we also have a nice blog post on the CNCF blog post with some high-level details on the application. Okay, so this is the logical vision of the application. When I start looking at what's in the box, things are getting a bit more complicated for now. So we need a PostgreSQL database. We also need a Kafka broker to receive and to broadcast events. And obviously, our kitchen and delivery and store events need a Kafka client and a JDBC driver. So far so good. It's still easily understandable, okay? And from that, we will try to transform this application in a more enterprise-ish application one. So before diving in, who we are. So my name is Laurent. I'm working at Postman. When I'm fully dedicated to the Microcks project I founded some years ago, and Microcks is a CNCF project I'll talk about much more in a few minutes.
Hi folks, thank you so much for joining at this late hour. My name is Artur, I'm from Adobe. I have been Java SDK Dapr maintainer for the last 1 year. And in this talk I'll try to share some light what is Dapr and how we can use it and how we can make your applications portable.
Okay, so we have a very naive application so far, and we want to transform it into an enterprise application. What do we need? So we need a lot of stuff. We need, of course, to take care about connection pools, to tune the connection pools. We probably need to manage security, to connect to an external IDP. We probably need at some point to retrieve some secrets, to be connected with vaults, to be connected maybe with a cache to have much more performance. And probably we also need some resiliency features. We need to add fault tolerance, we need to add retries to circuit breaker, and so on and so forth. And so for that, we have the traditional approach. I would say we can select and pick different kinds of libraries and put everything into our application. This works well if we just have to manage one technology stack, but if we are a big enterprise, we probably have to manage a Java stack, .NET stack, maybe TypeScript, Golang, this kind of stuff, and it's become really hard to find consistent libraries in each and every languages, but which probably have a better approach. What do you think, Artur?
Sure. So, meet Dapr. Raise hands, who knows what is Dapr? Like, have you heard about it? Okay. Are you using it in production, anywhere? Jesus. Okay, then I think we should work more on our marketing pitch. Okay, so Dapr is a CNCF graduated project. It actually graduated last year at KubeCon, if I'm not mistaken, so it's ready for production, and it has been ready for production a long time ago, so you should definitely check it out and use it. Dapr comes with its own set of APIs. It has HTTP and gRPC, but we also provide a lot of SDKs for the most used languages like Python, TypeScript, JavaScript, Go, .NET, and so on. So the SDKs are optional. If you want to use it, great. If you don't want to use it, you can go like hardcore and use APIs directly, gRPC or HTTP. And there is also a lot of case studies, and you can look at it, how people are using Dapr in production. At a very high level, Dapr can be separated into three different layers. At the first layer, you have the application layer. So basically, at the application layer, as I said, you can go native and use Dapr provided APIs like HTTP or gRPC, or you can opt in to use the SDKs. I know Laurent mentioned that, oh, you should not use, I mean, we already have SDKs, and it's just like yet another SDKs. But bear with me, because this is like really important. In the middle layer, we have the Dapr runtime itself, and at the lowest layer, we have the compute, which can be Kubernetes, it can be your on-prem, your own cloud provider, or if you want to get really fancy, you can run Dapr at the edge. It's all possible and doable. I want to spend a little bit more time on the Dapr runtime itself. The premise of Dapr was to codify all the best practices that people have found across the industries, especially at Microsoft Azure, related to distributed applications. So it has a lot of building blocks that allows you to connect to different services and abstracts away all this complexity. So instead of using, like, I'm coming from Java perspective. So in Java, you have Spring, and at Spring, you have like JDBC drivers for SQL databases, you have Mongo drivers, you have DynamoDB drivers if you're using AWS, and so on and so forth. The list can go on. And just one single Java application contains a gazillions of dependencies that you have to patch, you have to manage, you have to upgrade, you have to fix CVEs, and so on. With Dapr, all of this kind of fades away because you have to want just one dependency. You depend on Dapr, and that's it. Like literally, that's it. You don't have to worry about all of that. So Dapr kind of provides this layer of abstraction that makes your application truly portable across clouds, across storages, across message brokers, and so on. So without going into much details, the building blocks that I wanted to highlight, which are really important, is the PubSub, which allows you to do publish, subscribe, the usual stuff. For those that know Kafka and Redis, PubSub, and all that, it's kind of that abstraction. The next, you have the actors. For people familiar with Microsoft Orleans, Dapr implements the virtual actor pattern, which is really useful when you have to deal with stateful entities across the life of an application, or if you want to implement digital pins or dealing with IoT devices and stuff like that is really important. And there are many more. One of the last additions to the whole Dapr ecosystem and building blocks is Dapr Workflows, which implements the durable execution pattern. For those familiar with temporal, it's kind of the same idea, but it's implemented a little bit in an agnostic way, because temporal depends on SQL databases and Cassandra and some other things like that, but at the end of the day, it's tied to some storage. Dapr is kind of storage agnostic. It makes it a little bit different in this regard, and I think it goes back to the same idea that it makes your applications portable. And I cannot emphasize this enough. And besides all these building blocks, Dapr also allows you to externalize all the different policies that you might have to make your application resilient. For example, again, going back to Java, if you want to connect to an external service, you'll probably have circuit breakers, timeouts, retries, you name it. All of that is still important with Dapr, but you can externalize them as configurations via YAML manifests, which are very similar to Kubernetes manifests. And this makes it really easy to play around with different configs and figure it out like what works best in this particular scenario. In the pizza store example that Laurent showed, we are using one of the building blocks, which is called service-to-service invocation. And the nice things about this particular building block is that Dapr mediates all the communication between the services. So service A communicates with service B, and they are completely decoupled. The only thing that they have to know about each other is that service A will connect to localhost and Dapr port, and that's it. On the other side of the receiving end, the server should expose an HTTP endpoint, and that's all. It's like literally that simple. You don't have to do any shenanigans or dealing with any complexity. And you might ask, okay, but if I have a fleet of services, or how do I do service discovery and all that jazz? Dapr can handle this for you, and it has different connections, and it can use different DNS providers and whatnot. So it's really, really flexible in this regard. One of the really interesting things related to Dapr and how it enhances the communication between the services is the security aspect. We know that security is important and all that, but people actually forget about it or doing it later. What is interesting with Dapr is that it can actually enhances your security posture, because if you put the Dapr in between your services, it can actually, all the communication can be via MTLS. I'm not sure if anyone tried to use MTLS and implement it in their org. It's a pain. I mean, if you say it's not, I don't believe you. It's really painful. With Dapr, this is handled out of the box because Dapr authors spent a lot of time on making it this, I mean, I wouldn't say trivial, but definitely easier than anything else I have seen. So in the pizza store, as I mentioned, to make your application resilient, it's again the same model. The programming model is pretty much the same. You have Dapr in between, and you can configure for different endpoints, different policies. Like for one endpoint, for example, one of the services is, that's a little bit finicky, and you have to do more retries for whatever reason. You can externalize that, and it will be part of the Dapr configuration, communicating with that particular service. For others, if you want to enhance the security and you want to use a more sophisticated security scheme, it's also doable, and you can do that. And as part of the pizza store, Laurent mentioned that we have the Kafka broker in between. So it's important to highlight that Dapr has all these building blocks, but all of them are using a very simple programming model. For example, for PubSub, we have you literally use HTTP client to publish a JSON, and on the other end, you expose an HTTP point that receives the JSON. That's all. All the complexity is hidden away, and here in Dapr we have a lot of components that has been contributed either by Dapr core maintainers or by the community. So here are just a few icons, but on the Dapr website you'll find many more. And the last one which I want to touch here is that in this particular case we have Kafka broker and all the complexity to deal with Kafka brokers and partitions and topics and all that nice things, I guess, if you are into Kafka. All of that is handled by Dapr, and again, as a programmer, you don't have to know about all of that. You can focus on the business logic. I just want to make sure that people understand that you cannot be expert in everything. So at this stage, especially with AI and whatnot, you should probably focus on the business logic and the value added that you can have, and let other team members, like, I don't know, platform engineers or SRE people, deal with all this complexity at the communication layer. Either you communicate with Kafka or anything else, it doesn't really matter, but you need people that know what they are doing. Expecting that everyone knows Kafka is a little bit like, I don't think it's a good idea.
Yeah. And the nice benefit of that is that you can switch the broker implementation when you want. So typically from the application point of view, it doesn't change a thing if you're running with Kafka today, RabbitMQ tomorrow, SQS, SNS just after. It's up to you to choose the right implementation at deployment time. Okay, conclusion of our part one.
Yeah, sure. So we have covered Dapr. Dapr is a CNCF project. Dapr is a good CNCF citizen. It integrates with everything that we have in the CNCF space, like Kubernetes, Istio, Mesh, and whatnot. It also uses cloud events extensively for everything that requires communication across services or sending data via message brokers or whatnot. We are using cloud events, which allows you to attach metadata and do all the other stuff that you need. I will try to reiterate that it makes your application portable, and since they are portable, it actually enhances testability because you are not depending on any implicit assumption when you're dealing with a message broker or something like that. And at the end of the day, I think that we can safely say that Dapr is a one-stop shop for your distributed applications.
Yeah, okay, so Dapr brings a lot of great features, but it also had a new dependencies. And okay, as developers, we are accustomed to manage dependencies, but have you ever felt this moment where you've been too far and introducing a new dependency breaks anything? Yeah, I'm sure. And yeah, developer experience is important, and we are at risk when introducing new service dependency because at the beginning, everything was very easy, I say. If I'm focusing on my store component, I just have to run a single command, but then I also have to pull all the dependencies and maybe use different building stacks, use different frameworks, use different tools, different language, different stacks. But still, sometimes I have to run some legacy stuff to deal with shell scripts and so on. So from a developer point of view, this is a very high cognitive load. You know, that's a real burden to remember everything, all those commands for your application, but also for all the dependencies you are using in your application. So that's the first point. The second one is about your developer's laptop configuration. Okay, you want just as a developer to focus on your application with your IDE, but probably you also have to manage your dependencies and maybe pull out a few containers. And if those dependencies are also microservices, they probably have their own database. And if you're in an enterprise application context, you probably have some brokers, some cache, and so on. And finally, at the end of the day, you probably have a Kubernetes cluster on your machine. And you know, like me, that's not very efficient. You burn a lot of resources. It's very complex. You burn a lot of resources, a lot of CPUs, and finally waste a lot of time and money. So here again, we should have a better way of doing this. So thankfully, a few years ago appears this library, Testcontainer. How many of you are aware of Testcontainers, are using it? Okay, cool. And so Testcontainers is really amazing because it provides different language SDK that allows you to pop out lightweight containers so that you easily can start with a uniform interface, PostgreSQL or Kafka Broker or whatever. But still, we have to deal with our regular business service, you know, the service we are developing in-house. And thankfully, those services are distributed. They represent APIs that represent promise that can be translated into contracts. And so the idea here is to reuse those contracts to provide simulations using Microcks. Microcks is a CNCF project, and it is purely focused on API simulation and API mocking and API testing. And the unique thing in Microcks is that it provides a very uniform way of doing things, whatever the style of API. It could be REST API, GraphQL API, gRPC, or event-driven API. How it works in a nutshell, you just have to collect the different artifacts you probably already have in your organization, OpenAPI files, gRPC protobuffer, maybe Postman collection, this kind of stuff, put everything into Microcks, and from that we are able to just provide simulation on-the-fly mock endpoint that your API consumer will be able to use without deploying a full set of containers, for example. The more artifacts you put in Microcks, the smartest are the mocks. And on the other hand, while we have also ingested all these artifacts, with Microcks we have this ability to build a comprehensive test suite for your API implementation. So once your API is developed and deployed, you can just ask Microcks, maybe from your CI/CD pipeline, to do some conformance checking for you and check that your application, your API is actually conformant to the latest version of your specification, but maybe also conformant to the previous one, so that you're sure you didn't introduce any breaking changes in your new release. And thankfully, both Dapr and Microcks are available as a test container extension. So here, the purpose and the goal of this demonstration is to use a test container to manage both the infrastructure side of things, PostgreSQL and Kafka, but also use the Dapr and the Microcks test container so that we will be able to provide very lightweight simulation of all our depending services. So this is the purpose of demo number 2. So here, demo number 2, I'm going to switch to the local instance of my application. And you can see here, right in top right corner, I don't have all the components. For the kitchen and the delivery service, I will only rely on a lightweight simulation that are provided by Microcks. And you see that despite I'm just having the store component locally, I can still order a pizza and a beer, place my order, and receive notification and execute the workflow seamlessly, even if I'm not actually wired to the real service. I have just integrated the Dapr test containers and the Microcks test container into my application, and at the startup of my application, it builds the simulation and wired everything together so I can reproduce the same configuration, but with a fraction of the cost and the consumed resources of the full application. I can show you just a fraction of code, just right here. You can see that here in Java, but it's exactly the same thing in Go, in TestScript, whatever. You just ask for starting a new Microcks container with a connection to your Kafka broker, and just asking Microcks to load different artifacts, OpenAPI file, a SIG API file, and from this, Microcks will succeed in producing mock simulations and to wire everything into your application so that you can work seamlessly with your application, even if you have bad Wi-Fi like today. The second thing that is super interesting with Microcks is that you also have contract testing for free. So contract testing is not new stuff, but it's traditionally a pain to implement because it's very verbose. It requires to write a lot of code. Here with Microcks, the approach is very different. You just, in your unit tests, have to launch a Microcks test, and because Microcks knows everything about the contracts, about the different data sets, about the different examples, it acts as a consumer of your APIs, and it just send request, receive response, and validate everything regarding the Open API schema. So here again, it's very easy as a developer to check that the API you are actually developing is not drifting from the specification and is still conformant with the current version, but also with the previous version of your specification. So here again, if I can show you some codes, writing a test here, a JUnit test is actually very easy. I'm just building a test request, here specifying the API I want to test, the interface contract I want to test, checking the OpenAPI schema conformance, launching the test in Microcks, and asserting the success. Don't have to write some complex HTTP stuff, checking status code, checking media type, and so on. Just asking Microcks to do this for me from all the contracts it has ingested before. So very easy to do contract testing at scale using many, many different versions of your API with Microcks. And obviously, you can do exactly the same thing using async API and event-driven API here. You can still use Microcks that will start a Kafka broker for you, that will check that your messaging SDK has been correctly invoked, that messages are sent over the wire to the correct Kafka topic, and above all, that your consumer will be able to deserialize and actually use your events. So everything here comes for free. You don't have to write some plumber things. It's just out of the box from with Microcks. So this is the end of part 2. So you can see that with Microcks, we have now this ability to ease the life of the developers managing more dependencies on your laptop without having to set up a complex environment that costs a lot, that requires a lot of resources. The simulations are very lightweight, but still we have great benefits regarding the confidence and the testability of all the systems, and we are sure we are not introducing breaking changes.
All right, so we have seen how we can use Dapr to make portable applications. We have seen Microcks, how we can make sure that our applications are actually testable and works as expected, conforming to schemas, API, and contracts. But the next question would be like, if we want to make our pizza delivery a little bit more resilient or more robust, then what we have seen with retried circuit breakers and timeouts is not enough. And as I mentioned, one of the last additions to Dapr is Dapr Workflows, and which implements the durable execution pattern. It actually allows you to have these long-running processes that even if they fail, you can move to a different machine and it can start replaying the events from the last known good state. This is immensely powerful. I mean, if you have used anything like temporal or durable functions from Microsoft, it's the same idea. However, in Dapr, it's implemented in a way that it's portable across storages, and it's portable across cloud providers and whatnot. So Dapr, just like temporal, for example, it uses the same approach as workflow as code. So instead of using, I don't know, YAMLs or JSON, or if you are familiar with UI tools where you can pretty much design your workflows, here you can use code. And as I said, it's inspired by Microsoft Azure Durable Functions. So it has the same ideas. You have workflows, you have activities. Activities are the stuff that you normally are side effective. For example, you send a request, you publish something to a Kafka topic, you do a random value or anything like that. Those should be wrapped in activities. And the workflow is a step-by-step execution where you actually use activities to implement your steps. And as I said, it's immensely powerful. Once you get used to it, you will probably don't want to go back to anything else, because once your process dies, normally you lost everything. Here it dies, it moves to a different machine, and it just moves on. And the very important aspect of this is that usually when we are dealing with business processes, we are thinking like, I don't know, maybe seconds or minutes. Dapr Workflows allows you to have long-running workflows, which can be days, months, even years if you really have to.
Okay. Maybe I'm going to jump to the last part of the demo before the conclusion. So this is the moment where we have to introduce AI in the demo, you know, and typically this is what we've done in front of the workflow execution, and we just want to create an order using a simple prompt. And just show you the demo before the conclusion. So here I have to, to refresh, check, and set an AI prompt. I want pepperoni and beer. And here you can see that I can send a prompt and it's processed by AI, and then it can execute the workflow in the same way that before. Here, just one thing that you can notice is that it's very fast to execute. Yes, because in the inner loop, we don't necessarily want to wait for the LLM, and also to spend a lot on tokens. And each and every time we want to check our application. So what we've done in this demo is that we have simply mocked the OpenAI API using Microcks as well. And the only thing we have to do here is just provide a simple YAML file saying that when you receive the request about pepperoni and beer, for example, you just have to provide a response with this JSON that is the structured output we expect from the LLM. And thus, locally, without even having to wait for the LLM to spend many tokens with the OpenAI service, I can test everything locally thanks to very lightweight simulation provided by Microcks and also wired automatically into my application locally.
So it's still AI, but it's actual intelligence, not artificial intelligence.
Yeah, so time to conclude. So what we have today, can you just sum up things, Artur?
Yeah, so what we have seen so far is that making application resilient takes a lot of effort. Dapr makes it, I wouldn't say trivial, but definitely it makes it easier. And the most important part is that it codifies things that we already know that we have to do. But it pushes into the abstraction that at the lower layers that you don't have to deal with.
Yeah, exactly. And still, you may think that introducing new dependencies, new libraries, can be a pain for the developers, but still, if you're using things like Microcks to provide lightweight simulation, you will see that you really ease the life of developers, don't having to know a lot of commands, to remember those commands, and to pull out the whole universe just to work on a simple component. So really, Dapr plus Microcks makes things easy for both developers and operations, and that whatever the stacks, because both SDKs and Testcontainers modules are available on Java, on .NET, on Golang, on TypeScript, and whatever. So thanks a lot for your attention.
Yeah, thanks a lot for staying late. Thank you so much.
And if you want to give us feedback, do not hesitate. Scan the QR code and just provide feedbacks via the SCAD application. Thanks.
Thank you so much.